Hello everyone. Therefore, we are dealing with this problem. Problem is that an aluminum wire having a diameter T equal to D equal to 2 millimeter and length is 3.8 meter is subjected to a tensile load P. The maximum aluminium has modulus of elasticity is equal to 75 gigapascal. If the maximum permissible elongation of the wire is 3 millimeter and the allowable stress in tension is 60 megapascal, what is the load P max we can apply? So let me collect the information what is given. Information is given diameter is 2 mm. Okay, and what is length is given 3.8 meter. I need to convert in millimeter. 3.8 into 10 ki power 3, it is coming at millimeter. So length is 3.8 into 333, so it is 3800 millimeter. Okay, length is coming like that, and it is given modulus of elasticity E is 75 gigapascal. I will write down in millimeter. It will 75 into 10 ki power 3 megapascal. Or bracket में we can see that this is Newton per millimeter square. How? I will show you. 1 gigapascal is equal to the 10 ki power 9 pascal. Okay. I can write out 10 ki power 9 into 10 ki power 6 Pascal. One thing I know, 1 megapascal is equal to the 10 ki power 6 Pascal. So this is megapascal, and so 1 gigapascal is equal to the 10 ki power 3 megapascal. Okay, based on that I directly written 25 into 10 ki power 3 megapascal, that is in Newton per millimeter square. Okay, so let me proceed further. So E is given. It is telling that maximum elongation, that means delta L is 3 millimeter, and it is also allowable stress. Sigma allowable is 60 megapascal. It is asking what is the P max load we calculate. So based on two things, two method we can calculate it. Okay. So let me consider two cases. Okay, first one is like that. We can have formula tau allowable is P by A. Tau allowable is 60 megapascal. P we don't know. Area is pi into 1 square. P is equal to 60 into pi. How much it will value came? Value is coming P is equal to 188.495 Newton. I can write out 188.5 Newton. This is the one case. I got it. Now second case, delta L by L is P by AE. Delta L we know how much? 3. Length we know how much? Look at 3800. 3800. P I don't know. Area same, pi into 1 square. E is 75 into 10 ki power 3. Okay, now calculate the P, how much it will came. 3 into pi into 75 into 10 ki power 3 upon 3800. How much it will came? Let me calculate. So it is coming as 185.92 Newton. Okay, these two cases is came. Which I will take P maximum? This case or this case? So this is the allowable. This is, we can apply this sigma allowable is 50 megas. Let me take for verification for me, because elongation is only 3 millimeter. I calculated by elongation value, elongation formula. I know if I apply the 185.92 mega 2 Newton force, so elongation will be 3 millimeter. If I apply the force 188.5 Newton, elongation will be more than 3. So for it is telling that, question is telling that if the maximum permissible elongation of the wire is 3 mm, it means how much maximum wire will be long, it is 3 millimeter. For that case I want to know the force. So for that case I will apply the 185.92 Newton. If apply more than 180.92, the elongation will be more. Let me prove it. Okay, for verification, let me calculate delta L is equal to PL by AE. Let me put delta L, P how much? 188.5. Length we know 3800. Area pi into 1 square is 7530. How much it is coming? Let me calculate. So the elongation is coming 3.04. Okay, so millimeter, it is more than 3. So I will apply only 185.92 Newton. This is the our P maximum we can apply for 3 millimeter elongation. How now? Second part is coming. How do I verify with FEM? How do I verify with FEM? For FEM, what I will do? What output I will get from FEM? I will get stress. I will get elongation. So we get from these things. So what we give the give input. First step is geometry, or geometry we will give length is equal to 38 3800 millimeters. Let me again cross verify. It is 3.8 3800 millimeter. Okay, this is our geometry. Second case we will generate the mesh. Third case we will apply the material. For material, what is the material? This is the aluminum wire. This is the aluminum. I will give the Young modulus E is equal to 7530. Okay, Newton per millimeter square, in bracket you can say it megapascal. Okay, the our fourth case I will define the property. For property I need, so this is the wire. I will select the circle. For that I need radius, that is 1 millimeter, because diameter is given 2 millimeter. Okay, fifth case we can apply the load. So I will fix one end I will fix it. Okay, and second end I will apply the load. How much? P is equal to 188 185.92 Newton. We are accepting delta L. How much we will get? Let me verify. Okay,